Lesson 5.4 Multi-Turn Conversation Training. Overview. The science behind it is fascinating. Through careful analysis and practice, you'll master these techniques quickly. Real conversations don't work like a FAQ page. They're living threads, each message building on the last, with pronouns that point backward, ideas that evolve, and context that compounds. Training a model to handle that kind of dialogue is a genuinely different challenge from single-turn fine-tuning. And that's exactly what this lesson covers. By the end, you'll know how to build multi-turn datasets, manage context window constraints, and train a model that stays coherent and consistent across an entire conversation. Expect about 90 minutes of work, pitched at an intermediate to advanced level. Learning objectives. Fas os ekna fis. Here's what you'll be able to do when this lesson is done. You'll create multi-turn conversation datasets from scratch, handle conversation history and context correctly, train models for genuine dialogue coherence, manage context window constraints so long conversations don't break things, test multi-turn quality interactively, and handle conversation breakdowns gracefully when the model loses the thread. Single-turn versus multi-turn. This is the JSON structure for a single-turn conversation. There is a system message that sets the assistant's role, one user message asking a Python question, and one assistant response. Clean and simple, the model sees this, learns the pattern, and gets good at answering isolated questions. But notice what's missing. There's no history, no follow-up, no what did we just talk about. Every interaction is a blank slate. That's the defining characteristic of single-turn data, and it's also its fundamental limitation. One question, one answer. No conversation history. Each interaction is completely independent of everything that came before it. This is the multi-turn version. The messages array now contains a full back and forth. The user asks about Python, the assistant answers, the user follows up with what about lists, and the assistant continues the thread. Notice the word what about. That phrase only makes sense if you remember what came before. The model has to understand that lists is being compared to whatever was just discussed. That's the core skill multi-turn training develops. Reading the full conversation history, not just the most recent message. Multiple back and forth exchanges, references to previous messages, words like it and what about, a maintained conversation thread, responses that are aware of everything said before them. Why multi-turn is challenging? Why multi-turn is challenging? Why multi-turn is Iruan Koshk? The model has to juggle several things simultaneously. What topics were discussed earlier? What is the user ultimately trying to accomplish? What information has already been given so it doesn't repeat itself? And which questions from earlier still need a proper follow-up? That's a lot of state to track. Here's a concrete example of what failure looks like. Picture this exchange. The user says, I keep getting a geeker in my dictionary code. The assistant explains what a geeker is, and then 3 turns later the user asks, how do I use it? A well-trained model knows it refers to the dictionary, specifically the one causing the key tour 2 turns back. A poorly trained model treats that pronoun as ambiguous and either guesses wrong or asks a clarifying question that makes no sense given the context. The failure mode here isn't a hallucination, it's a loss of referential awareness. Your training data teaches the model to map pronouns and vague references back to the concrete concepts they point to. When a user says, how do I use it? The model must resolve what it actually means. The tool mentioned 2 turns ago, the function from the last response, the concept introduced at the start. Training on well-constructed multi-turn data teaches the model to perform that resolution correctly, connecting pronouns to the specific concepts they refer to earlier in the conversation. There's a second challenge beyond context tracking: personality consistency. The assistant's tone and character must stay stable across every single turn. This example shows what personality drift looks like. Turns 1 and 2 are enthusiastic and warm. Turn 3 suddenly goes flat and clinical. From the user's perspective, it feels like they're talking to a different person. That inconsistency erodes trust fast. Your training data needs to model consistent personality throughout the entire conversation, not just in the opening turns where the assistant is freshly initialized. Repetition is a related failure mode, and this example shows how it compounds over time. Turn 1 gives a clear, useful answer. Turn 3 restates the same idea, acceptable. Turn 5 says it again, now it's noticeable. Turn 7 says it a fourth time. That's a broken model. The problem isn't that the model is wrong, it's that it's stuck. Good multi-turn training teaches the model when to reference earlier information and when to move the conversation forward instead of cycling back to it. The model needs to know when to reference what was already said and when to simply move forward. Creating multi-turn datasets. This JSON example shows a well-constructed tech support conversation. The system message establishes a patient clarifying tone. The user opens with a vague problem: "My computer won't connect to the internet." The assistant doesn't just dump a list of fixes, it asks a targeted question to narrow down the issue. The user gives more detail: "It was working yesterday." The assistant picks up on that clue and suggests a specific diagnostic step. The conversation ends with the user confirming it worked. What makes this excellent training data is the progressive information gathering. Each assistant turn builds directly on what the user just said, and the final resolution is earned through that process, not guessed at from the opening message. 5 things make this good multi-turn data. Context tracking. Each response builds on the previous one. Pronoun usage, it, that, and the old USB port all refer back to specific earlier mentions. Situational awareness. The assistant remembers the error message and the solution that was already tried. Progressive problem solving. Gather information, suggest a solution, confirm success, and natural flow. It reads like a real support interaction, not a scripted FAQ. This second example shows a creative writing coaching conversation. The system prompt establishes an enthusiastic writing coach persona. The user shares a struggle with world building, and the assistant responds with targeted questions rather than generic advice. As the conversation develops, the assistant builds directly on the user's answers, introducing concepts like elemental magic and honor systems that grow organically from what the user described. Notice the energy. "Oh yes," and "right" aren't decoration, they're part of what the model needs to learn. Personality is data. The assistant's enthusiasm has to be consistent and earned, not just bolted on at the start. 5 things make this excellent multi-turn data. Ideas build progressively. Each turn develops the concept further rather than restating it. Progress gets celebrated. The assistant's excitement is genuine and tracked across turns. The conversation thread is maintained. References to "your world," "this idea," and "oath breaking" all point back to specific earlier exchanges. Personality stays consistent throughout all 5 turns, and the topic progression is natural: problem, exploration, specific idea, shared excitement, next steps. Multi-turn data guidelines. Y-lines. Vailanda decent Y-lines these techniques quickly. Turn count maps directly to difficulty. 2 to 3 turns is easy. Basic follow-ups and clarifications. 4 to 5 turns is medium, standard conversations and problem solving. 6 to 8 turns is hard, complex topics and extended support. 9 or more turns is very hard, deep consultations and long form coaching. The recommended mix for a balanced training dataset: 60% 2 to 3 turn conversations, 30% 4 to 5 turn, and 10% 6 or more. That ratio gives the model a strong foundation in short exchanges while still exposing it to the harder, longer patterns. Here's the standard tech support conversation arc. Turn 1. User asks a broad question. Turn 2. Assistant asks clarifying questions to understand the specific situation. Turn 3. User provides. Turn 4. Assistant offers a targeted solution based on those details. Turn 5. User confirms whether it worked or asks a follow-up. Turn 6. Assistant either elaborates or closes out the conversation cleanly. This structure teaches the model to resist jumping to solutions before it has enough information, a habit that makes support interactions dramatically more useful. This arc works best for tech support, consulting, and troubleshooting scenarios. The creative arc runs differently. Turn 1. User presents an initial idea. Turn 2. Assistant expands on it and asks a focusing question. Turn 3. User picks a direction. Turn 4. Assistant develops that direction with depth. Turn 5. User adds more detail or a new constraint. Turn 6. Assistant synthesizes everything and proposes concrete next steps. The key difference from the support arc is that the conversation isn't converging on a single correct answer. It's expanding and exploring. Your training data needs to capture that generative, open-ended quality. This arc works best for creative work, brainstorming, and planning sessions. The teaching arc is the most structured of the three. Turn 1. User asks a basic question. Turn 2. Assistant gives a simple, clear explanation. Turn 3. User asks for more depth. Turn 4. Assistant provides a deeper explanation. Turn 5. User asks how to apply it. Turn 6. Assistant gives practical examples. Notice the deliberate pacing. Simple before deep. Concept before application. Training on this arc teaches the model to read where the user is in their understanding and match the explanation level accordingly, rather than front-loading everything at once. This arc works best for tutoring, teaching, and step-by-step explanations. Building multi-turn training data. This code builds your training data set file. The conversations list holds your structured message arrays, each one a complete multi-turn exchange with system prompt, user turns, and assistant responses. The with open block writes each conversation to a file called multiturn_train.jsonl, 1 JSON object per line. That JSONL format, JSON lines, is the standard for training datasets because it's streamable. You can process one conversation at a time without loading the entire file into memory. When this runs, each conversation lands on its own line, correctly formatted and ready for the training pipeline. Budget roughly 5 to 10 minutes per conversation for quality handcrafted data. To build a solid dataset of 200 to 300 conversations, expect to invest somewhere between 20 and 40 hours. That's the real cost of multi-turn training, and it's worth knowing upfront. This code automates the conversation generation process using a base model to bootstrap your dataset. It loads a pre-trained Llama 3.2 model with a 2048 token sequence length and 4-bit quantization for memory efficiency. The generate_conversation function takes a system prompt and an initial user query, then runs for a specified number of turns, each time feeding the full conversation history back through the model to generate the next assistant response. The temperature parameter controls how creative versus conservative those responses are. After generation, all conversations are saved to a JSON-L file. The critical step that this code does not do for you: manual review. Generated data contains errors, repetitions, and off-tone responses. You must read through and edit every conversation before it goes into training. Generated data is a starting point, not a finished product. Manual review and editing is not optional. It's what separates good training data from noise. There's a faster way to build multi-turn data if you already have single-turn examples. Start with what you have, then expand it by inserting turns in the middle. Here's the technique. You start with a single turn example. User asks, "How do I sort a list in Python?" and the assistant gives a one-line answer. The expanded version keeps that opening and closing, but inserts clarifying turns in between. The assistant asks whether the user wants ascending or descending order. The user specifies, and then the assistant explains both sorted and sorted with the distinction between them. The final answer is now more useful because it's tailored. This expansion method is faster than writing from scratch because the opening question and closing answer are already done. You're just building the middle of the conversation. Expanding existing single-turn examples is significantly faster than building multi-turn conversations from scratch. Use what you already have. Training on multi-turn data. The training code itself looks almost identical to what you've used before. The model learns from the conversation structure automatically. You don't need a special multi-turn training loop. Here's the full setup. This code sets up the complete multi-turn training pipeline. The model loads with a 2048 token sequence length. Bump that to 4096 if your conversations are long. LoRa is applied with the standard parameters. R controls the rank of the adaptation matrices. LoRa_alpha scales the learnet updates, and LoRa_dropout prevents overfitting on small datasets. Training and validation datasets load from your JSON-L files, and the formatting function applies the chat template to each conversation before it reaches the model. The SFT trainer handles the rest: batching, gradient accumulation, evaluation against the validation set. When training completes, the model and tokenizer are saved to disk. The output you're looking for is the loss curve dropping consistently across epochs. That's confirmation the model is learning the conversation structure. That's the entire training setup. The model learns context, coherence, and personality consistency directly from the conversation structure in your data. No special configuration required beyond what you see here. Testing multi-turn conversations. This code sets up an interactive chat loop for testing your fine-tuned model. The model loads with 4-bit quantization and a 2048 token sequence length. The chat function initializes with a system prompt, then enters a loop, capturing user input, appending it to the conversation history, generating a response, and printing it. The max_new_tokens parameter caps response length, and temperature controls creativity. Type quit to exit. The reason you test interactively rather than with automated benchmarks is that conversation flow problems are invisible to automated metrics. You have to actually talk to the model to discover whether it remembers what you said 3 turns ago, whether it stays in character, and whether it knows when to move forward versus when to reference earlier context. This evaluation rubric gives you a structured way to score your model's conversation quality. 5 categories: context tracking, coherence, consistency, responsiveness, and conversation management, each rated 1 to 5. A total score below 15 means there are significant problems to fix. Scores between 15 and 20 indicate a solid foundation that's ready for further refinement. Anything above 21 is excellent. Run several different conversation scenarios through this rubric: tech support, creative work, teaching, because a model can score well on one type and poorly on another. Common multi-turn issues. The first common failure is context amnesia. The model forgets what was established earlier in the conversation. Here's what that looks like. Turn 1 establishes clearly, "I'm building a web app with Flask." The conversation continues for several turns about Flask-specific topics. Then turn 5 arrives. Should I use Django or Flask for this? The model has forgotten that Flask was already chosen. That's context amnesia. The model isn't being evasive, it literally lost track of the earlier information. 3 fixes address this. Increase max underscore seek underscore length to 4096 or 8192 so earlier turns aren't getting cut off. Add more training examples where the assistant explicitly references earlier turns. And reduce conversation length in your training data if the conversations are consistently exceeding your token budget. 3 fixes for context amnesia. Increase max underscore seek underscore length to 4096 or 8192. Add more training examples where the model references earlier turns and reduce conversation length in training data if it's consistently. The second common failure is repetition. The model keeps restating the same information across turns. Here's what that looks like. The phrase Python is easy to learn appears in turn 1, turn 3, and turn 5. By turn 5, that's the third time the model has said essentially the same thing, and it's marked as a failure. The model isn't wrong, it's stuck. It knows one relevant fact and keeps returning to it instead of building on it or moving the conversation forward. 3 fixes. Add training examples that show varied phrasing of the same concept. Include examples where the assistant explicitly moves past a point it already covered. And use a temperature above 0.7 during inference to introduce enough variation that the model doesn't collapse onto its most probable phrase. 3 fixes for repetition. Add training examples with varied phrasing. Include examples where the assistant moves the conversation forward past covered ground and use temperature above 0.7 during inference. The third common failure is topic drift. The conversation wanders away from what the user actually asked about. Here's what that looks like. The user asks about data preparation. The assistant's response wanders into neural network architecture, a related topic, but not what was asked. From the user's perspective, their question went unanswered. Topic drift is particularly insidious because the model's response often sounds plausible. It's not nonsense, it's just off target. 3 fixes. Add more training examples that stay tightly focused on the user's stated topic. Audit your training data to ensure follow-up turns stay on thread, and consider upgrading to a higher quality base model if drift persists after data improvements. Free fixes for topic drift. Add focused training examples, ensure follow-up turns in your training data stay on topic, and consider a higher quality base model if the problem persists. Complete multi-turn training notebook. This is the complete notebook that ties everything together. It imports fast language model and SFT trainer from Unsloth, loads the model with a 2048 token sequence length and 4-bit quantization, then loads your training and validation JSON-L files. The formatting function applies the chat template to each conversation, aligning the input structure with what the model expects. Training arguments specify epochs, batch size, and learning rate. The SFT trainer runs the full training loop. After training completes, the model and tokenizer are saved to disk. Both print statements confirm successful completion. The interactive test block at the bottom lets you immediately verify the trained model in a live conversation. Save this notebook to notebook/04-chat-models/03-multiturn-training.ipnb. Lesson checklist. Key takeaways. 6 things to carry forward from this lesson. Multi-turn training requires conversation-aware data, not just question-answer pairs. Context tracking is a learned behavior. More multi-turn examples in your dataset means better context retention in the model. Max sequence length is a hard constraint. Long conversations need 4096 or 8192 tokens, not 2048. Interactive testing is irreplaceable. Automated metrics cannot balance your turn counts. A mix of short and long conversations produces a more robust model than training on one length exclusively. And consistency is the hardest part. Personality must persist across every turn, not just the first few. What's next? Multi-turn conversation training is now in your toolkit. The next lesson pushes further. Lesson 5.5 covers advanced chat techniques, where you will go beyond basic dialogue structure into more sophisticated control over how your model converses. Additional resources. 3 areas worth exploring as you go deeper. Dialogue state tracking, which covers the formal study of how models maintain conversation state. Multi-turn conversation models, the research literature on architectures and training approaches, and context management strategies, practical techniques for handling conversations that exceed your token budget. Your model can now hold a real conversation. The next step is making it exceptional. This diagram shows the fundamental structure of a multi-turn training example. Everything starts with a system prompt. That's the context that frames the entire conversation. From there, the interaction alternates: user turn 1, assistant turn 1, user turn 2, assistant turn 2, and so on. The critical detail is at the bottom of the diagram. All of those turns get passed to the model as a single combined context. The model doesn't see individual messages in isolation. It sees the entire conversation history up to the current point. That's what enables context tracking, pronoun resolution, and coherent follow-ups. When you structure your training data, you're teaching the model to read that full history and generate the next response with all of it in mind. This graph shows something every multi-turn practitioner runs into eventually: context window exhaustion. The horizontal axis is conversation turns, the vertical axis is token. The stacked bars show how tokens accumulate: system prompt at the bottom, then user turns, then assistant turns layering on top. The dashed horizontal lines mark the 4K, 8K, and 32K context limits. Notice how token usage climbs steadily with each turn. Once you cross a context limit, the model starts dropping the earliest parts of the conversation to make room for the new content. That's when context amnesia appears, not because the model forgot, but because the earlier turns literally aren't in the input anymore. The practical implication: monitor your average conversation token count during dataset construction and set max_sake_length to match your actual data, not just. When a conversation exceeds your context window, you have 4 practical strategies. First, summarize early turns. Condense the first several exchanges into a compact summary that preserves the key facts without consuming as many tokens. Second, keep only key facts. Strip the conversation down to the information that's actually relevant to the current question. Third, use a sliding window. Maintain a fixed size buffer of the most recent tokens, accepting that very early context will be lost. Fourth, and most sophisticated, summarize turns dynamically. Generate a running summary that gets updated as the conversation progresses, giving the model a compressed but coherent history. Each strategy involves a trade-off between context fidelity and token budget. For most use cases, the sliding window or summarization approach gives the best balance of quality and cost. This diagram illustrates loss masking, one of the most important concepts in multi-turn training. The top row shows tokens where the loss is masked, meaning those tokens don't contribute to the gradient update during training. These are the input tokens: the system prompt, user messages, and earlier assistant turns. The second row shows tokens marked for training. These are the tokens in the current assistant response. the ones the model is actually learning to generate. The reason for this distinction matters. You don't want the model to optimize for reproducing the user's questions. You want it to optimize for generating the correct assistant responses. By masking the loss on everything except the assistant's output, you focus the learning signal exactly where it belongs. Unsloth handles this automatically when you use the chat template formatting, but understanding why it works this way helps you debug problems when the loss curve behaves unexpectedly. When conversations exceed your context window, 5 truncation strategies are available, each with distinct trade-offs. Truncate oldest drops the earliest turns, simple to implement, but you lose background context that may still be relevant. Truncate middle keeps a fixed number of recent turns and drops the middle, preserves recency, but can remove important transitional information. Sliding window maintains a fixed token buffer of recent content, consistent input length, but hard cutoffs can split turns mid-sentence. Summarize turns condenses earlier exchanges into a summary, highest quality, but requires an additional inference call to generate the summary. Rank and keep scores each turn by relevance to the current question and retains only the highest scoring ones. The smartest selection, but requires a classification step. For most fine-tuning workflows, sliding window or summarized turns will give you the best results relative to the implementation effort. This diagram shows exactly which part of a training example the model learns from. The conversation contains a system message, a user question about pasta, an assistant response with cooking instructions, a follow-up question about sauces, and a final assistant response with sauce options. The arrow points to that last assistant response with the label train on this response only. That's the loss masking principle in action. The model's gradient update comes entirely from predicting that final assistant turn, not from the system prompt, not from the user messages, not from the early assistant turn. The full conversation history is present in the input, so the model has context, but only the final response contributes to learning. This is why the quality of your assistant responses matters far more than the quality of your user prompts when constructing training data. This evaluation framework gives you 6 concrete scenarios for stress testing your multi-turn model. Reference recall. Does the model correctly cite details from an earlier turn when asked? Contradiction detection. When the user contradicts themselves, does the model notice and address it or silently accept the inconsistency? Pronoun resolution. Can the model correctly resolve it and that across multiple turns without ambiguity? Context limit. When the conversation exceeds the token window, does the model degrade gracefully, asking for clarification, or does it hallucinate details it can no longer see? Topic switch. When the user abruptly changes subject, does the model acknowledge the shift and remain helpful? Long correction. If the user corrects something from 5 turns ago, does the model integrate that correction accurately going forward? Run your trained model through all 6 of these before declaring it production ready. Each one exposes a different failure mode, and a model that passes all 6 is genuinely conversation capable.